Auke Hoekstra, we're at the Intersolar in Munich, and I was just thinking about you. Every time I'm here and I see that the industry is growing 100%, I'm thinking about you because you made this fantastic slide. Do you remember that the EAA was just wonderful, showing the prediction about the solar industry and that it was a little bit stable and every time it grew 100%. So
Yeah,
the reason,
exactly, exactly. You see the thick black line. The reality is still increasing super fast, like God knows how. You know that better, 100% per year or something. And basically, the horizontal lines indicate that the EAR basically said, well, the industry will stop growing now. Well, I think
yeah,
you are the place that's living proof that the industry didn't stop growing.
yeah. Hey, what are you doing except for placing these kinds of things? I know that you work for the university. You have this neon research. What is exactly your business, Auke?
Yeah. So what I do actually do for a living is I model how we can transition from fossil fuels to renewable energy, including electric vehicles, including avoiding grid congestion, that sort of thing. So modeling that, that is actually what I do. And all these people, they're also working on parts of this problem of how do we get from fossil fuels to renewable energy.
Yeah. Okay. Yeah. So we know you because you basically are the great guy in debunking all the everything which the industry is saying, or institutions are saying that electric is much too expensive and that we will never be able to have EV.
And that the
You know.
CO2 out and that the CO2 emission of electric vehicles are much too big compared to normal vehicles.
Yeah.
All that kind of bullshit I sort of try to debunk on Twitter. Yeah, that's
Yeah.
right.
You're doing a great job on that. Okay. The
Thank you.
reason I'm asking you is, as you hear, is because I saw this article from you in Solar News, and it says, "Hey, is the Netherlands investing enough in large batteries?" You say, "Oh, we're going to invest 260 billion euro in the electric grid," and you say there's a lot of other ways to do this, and especially we have to invest in batteries. What are these other things, except if we do the batteries as the last one? What kind of things can we do to make the electric grid stable?
Yeah, so indeed, 236 billion is now planned the coming 10 years for mainly, as they call it, grid reinforcement. And
Hmm.
I'm basically saying with three things: peak avoidance, dynamic thermal rating, and batteries, we
Yeah,
could tackle a whole lot of that. Not everything, but maybe half. And it would cost us maybe a tenth. Well,
yeah.
maybe I'm
So let's
optimistic,
look
but
at
there's a
first what.
lot of potential there.
Yeah, peak avoidance,
Yeah, so
smart
peak
smart
avoidance
demand.
basically means that well, you know, the grid is made to deal with peaks, and the biggest peak in the year, that's how big the line basically needs to be to your home or business or whatever, right? The
Yeah.
biggest
Mhm.
peak in the year, because we never want electricity to fail.
Yeah.
But on average, we only use about one third of the electricity that is sort of given to us, sort of the peaks that the peak room that is given to us.
Hmm.
So my simple idea, or and it's not new, but we do it insufficiently, is basically if we can manage those peaks away, if we can simply make those peaks a little bit less high and use the energy on other moments of the day, for
Yeah.
example, with batteries, as I will describe shortly, but also by, for example, charging your electric vehicle at moments when there's no grid congestion, or
Yeah.
maybe using your heat pump or your company a little bit less at moments when
Yeah.
there's big peaks. We can already do a lot.
Okay. Then we
The
know
second
that, of
thing,
course. We know that, of course. But then the other way you came here is dynamic thermal rating. I mean, nobody has ever heard about it. What is that?
a lot of people do, for me it was I heard about it like 2 years ago, but only recently have I found out how important it is.
Yeah.
What it basically means, well, the electricity grid, the problem with it is that it gets too hot when you put too much electricity through it, right?
Yeah.
So the heat is basically your problem. The problem is not that you use the line, that you use too much electricity. The problem is that while you use too much electricity, the thing gets too hot. And when it melts, yeah, you have a very expensive problem. So before that happens, all kind of fuses blow. But actually, for example, in the middle of winter, you can use your electricity line maybe 50 or even 100% more than you think because it doesn't heat so fast. Or when you have a sudden peak, but it doesn't last for hours and hours, just lasts for, let's say, half an hour or something, then also the machinery doesn't have enough time to heat up. So
Yeah.
if you look at this, if you would use modern digital technology to monitor that every hour or something, you would see that you have a tremendous amount of basically unused capacity that you could now use. So it's
Okay.
basically another form of peak shaving. You have another sort of
Yeah.
extra room that's sort of baked in at the
Yeah.
moment that we don't use.
An extra capacity. But I mean, if I now go to this first thing, the peak shaving by using a whole bunch of batteries, aren't these batteries unbelievable expensive? I mean, I'm now going to investigate all the battery stuff which is here in Munich. In Germany, 80% of all the installations have batteries. In Belgium, about 60%. In the Netherlands, about 3%. Aren't they way too expensive?
Yeah, that's to be quite honest. I came to this game when batteries were about 1,500 euros per kilowatt hour for electric vehicles. And I was still in that mindset, but recently it has become clear to me that I am really underestimating what's happening in batteries. It's even stronger, it's even more profound, I would say, than what's happening in solar. And we don't see it yet because the graph you're now showing, it makes clear how batteries are growing exponentially, very predictably, with 59% per year. That's really strong growth over the last, since 2015 or something. And on the right, you see that plotted with a log graph, and you see that it's a really straight line.
Yeah.
And actually, this straight line matches our observed data with a 99.91% accuracy. So it's really a very predictable exponential growth of battery production.
Yeah.
And that means that we have this potential to learn a lot. And every time we produce more of something that's built in a factory, and if you go up to the beginning of the article, you see there in this graph, again, a very straight line. On the vertical axis, you see the price of batteries. And on your horizontal axis, also a log graph, both are log graphs, you see the amount of batteries we have produced.
Yeah.
And you see that, well, I can tell you that if you do the math on this line, fit a trend line to it, that again fits extremely well, that for every doubling of production, the energy, the price of batteries goes down with about 25%. So it's humongously cheaper if you produce more of it.
Okay. So if we go again a times factor of 10, the price will go, down 3/4.
Something like that. Yeah. If you double the price goes down. Yeah. Exactly.
Okay. But I mean, we also saw that with solar, that the price was going down, and even though every time we thought it cannot go down more. But I mean, with batteries, don't you have the cost of cobalt, and don't you have the price of nickel?
Exactly. And what I did with solar back then is I developed actually the method I'm using now for batteries for solar, because I thought, is it possible that the solar can really get this cheap? Because I always thought that extending these sort of experience curves, these learning curves, these things that you see in practice, always get you closer to the truth than trying to predict on your gut feeling. You trust the curve, as my friend Michael Liebreich often said. He founded Bloomberg New Energy Finance with that idea in mind. Yeah. And what you see then is for solar panels that actually the raw materials are really cheap for solar panels. As silicon could, in theory, become very cheap, and even if we use less and less and less. Now, batteries, the interesting thing there is that right now, for cars, we're using largely NMC batteries. Nickel, manganese, cobalt batteries for the cathode. This is pretty expensive stuff. So basically your cathode will, even if you have a very dense battery, which is a good thing because you need less material. For batteries, the lighter and better the batteries are, the cheaper they are. Very interesting. Yeah. Super light is super cheap, very different than with computers. But anyway, even with a super light NMC battery, you still pay about 50 euros, dollar per kilowatt hour for the nickel, manganese, cobalt, and then you pay another 10 euros or something for the lithium. So
Yeah.
that's the absolute bottom price. You can never
Yeah.
get lower than that. But
Yeah.
now, these lithium iron phosphate batteries are becoming super popular, and they have an energy density now of about 200 watts hours per kilogram. So that's about 2/3 of the best NMC batteries.
Yeah.
Not a huge difference. It's a difference, but not a huge difference. So increasingly used in, let's say, cheaper cars or cars with not the absolute maximum range. And these batteries, they last forever, and they are super cheap. The materials that were the NMC battery, the cathode cost about 50 euros. But the iron and phosphate in the cathode of this LFP battery, lithium iron phosphate battery, cost like $1, a little bit less actually. So it's incredibly, the only thing you're still paying for in terms of materials, of course you still have to produce the thing, etc. But in terms of materials is lithium. And now what we see happening is that sodium batteries are becoming super interesting. And sodium batteries are already a gigafactory built for them now, so they're beyond close to commercialization. They're now commercial. There's also grid batteries already made with sodium batteries.
Yeah.
And if you look at the material for sodium batteries, you can even replace the lithium, which was the only expensive component still left in your battery, and replace it with salt, basically natrium, which is the same as you have in the sea, salt.
So, and then you would go to $1.
Sorry.
And then you would go to $1 per kilowatt hour for the basic cost of materials.
And now, if you extrapolate the cost, as I showed you how you could say 25% cheaper for every doubling, and then just extrapolate the cost until 2030, right?
Yeah.
You would arrive at $8 per kilowatt hour. Now, I'm not saying batteries are going to be $8 per kilowatt hour. There's probably going to be all kind of reasons in terms of production cost, and you still have to ship the stuff, and there's profits. Well, but still, batteries are going to be very cheap. And if you think what that means for the grid, it's a game changer. We know, for example, in California, that we had this duck curve. Maybe you remember it, where a solar basically made itself so cheap that it was very hard to make money from it. And the peaks at the end and the start of the day, they became higher and higher, basically. Yep. Now we see that with batteries in California, this whole duck curve is flattening. The solar is becoming worth more, and the peaks at the beginning and the end of the day are getting flat. So with enough batteries, all these peaks and all these problems that we have with wind and solar, at least over the day, they completely disappear.
And if we have day, if we don't have it for the day anymore, I mean, I think we have one thing is the day and the week, but on the other hand, we have the year. Do you also have is that a separate issue? We should maybe not discuss it now.
It is a separate issue. So if you look at grid congestion, if you look at the value of wind and solar, if you look at how we create a completely new electricity grid, then batteries and these daily fluctuations are basically 99% of your problem and your answer. But for seasonal fluctuations, you're talking about molecules, for example, hydrogen, or if you have to ship it, e-methanol, or maybe you keep some gas and some biofuels at hand for about 5% or so of the energy that you still need for this seasonal fluctuations. And then maybe you even combine that with CCS, I don't know, but this is only 5%. We can get to 95% of our energy with a couple of gas peakers for life, 5% for the coming 20 years. And then we'll figure out how to get rid of those 5% too.
Great. Hey, last question before we leave. Thank you for solving, first the problems with electric driving and now the problems with the electric grid. Do your friends from which basically you have made popularized, are they now agreeing with you?
Well, to be quite honest, they are a little bit more in line with what I always said regarding solar panels. But regarding batteries, I'm going to do another special, I think, where I sort of make clear that their predictions about not only growth, but also the cost reduction in batteries are really, really conservative. I mean, look at, first of all, these prices to the left. You see that for some reason, until 2030, in China, they will have very cheap batteries behind the meter, and this improvement will never reach us in the West. And also, for some reason, even though batteries could become like 20, 30, maybe 50 or 60 euros per kilowatt hour,
Yeah.
they will get stuck on 290 kilowatt hour euro per kilowatt hour, dollar per kilowatt hour or so until 2030.
Yeah.
I think same thing is going wrong here as with the solar.
Yeah. Amazing. Okay. Yeah. So I don't know why they have such a hard time learning from their from their mistakes or from their predictions. So that would be great. Anyway,
They have
okay.
very complex models, and it's very hard to change. So actually, Vincent, maybe that's also something very interesting, I think, for the people in the audience. The people who know a certain area the best, the real experts on how things work now,
Yeah.
are often the people who find it hardest to understand that everything changes.
Like the car industry, the Germans are really good engineers. They're really experts, and they've had a huge problem
Simply
adapting
not
to this
imagine that
world.
the combustion engine will ever go away.
Yes, yes. And now it's all the fault of China, and it's all the fault. And we just need tariffs on top of that. But anyway, you helped us tremendously in years of doubt to say, hey, all these professors which were saying you first need to drive 300,000 kilometers before a battery of a car is being paid back. You said it was like 30 or 40, 50,000. And now you basically give us hope that batteries really can get under the 100, under the 50, and even under the 20. And then we can solve our daily problem with EV, which we really need because our grid is really trembling.
Exactly. And wind and solar will be worth much more.
Yes. Okay. And that will be
Thank you very
wonderful.
much, Vincent. Thanks for having me.
Yeah. Thanks. I'm going back to the trading floor and see what kind of reality we can see in compared to your vision. Thanks very much for your time, Auke.